Hi everyone, in this video we will learn how to evaluate the triple integration. This concept is similar to the double integration, but here we are dealing with the three variables. Suppose we have the function that depends upon x, y and z, which is a continuous function and defined over the closed and bounded region T in R cube, that is in a x, y, z plane. The triple integration of that function over the region T is written by this form, where this dv represents the volume element and it is often expressed as dx, dy, dz. As it is depending upon the three variable x and y, that's why we have taken the three different integration. One is with respect to x, second is with respect to y, and the third is with respect to z. One important application in a triple integration is calculating the volume of a given region. For example, if we take this function as a 1, in that case, this triple integration gives us the volume of this region. Now let's understand how to evaluate the triple integration. Consider the following example. We have this example where we need to evaluate the triple integration with respect to x, y and z. The process is same. First we will take the integration with respect to x, then with respect to y, then with respect to z. It means this inner integral limits are for the x variable, middle one is for the y, and the outer integration limits are for the z. Now integrate with respect to x, that is x cube by 3, y square as it is, z square as it is, and the limit of x is equal to 0 to c, and the rest of the integral as it is. In the next step, substitute the limits of x, y square, z square as it is. The limit of x is c cube by 3 minus 0 by 3, that is 0. So simply we are getting in this case as c cube by 3. Now take the integration with respect to y. In that case, z square c cube by 3 is a constant and the integration of y square is y cube by 3 and the outer integration for z is as it is. And the limit of y is equal to 0 to b. In the next step, substitute the limit for y. That gives b cube by 3 minus lower limit 0. Now integrate with respect to z. In that case, c cube b cube by 9 is a constant. Take integration with respect to z, that is z cube by 3 and the limit of z is 0 to a. This is further is equal to substitute upper limit of z as a minus lower limit of z as a 0. This will further give you a cube into b cube into c cube by 27. This is how we are evaluating the triple integration in general. Whereas we have a property of the triple integration if we are dealing with a triple integration or a double integration, and we can separate the function in form of x, y and z. Moreover, the limits are constant. Suppose in this case is a to b, then c to d, then e to f. In that case, we can evaluate this integration directly by splitting these integrations. That is, for x the function is fx and the limit of x in this case is a to b into integrate with respect to y and the function of y is gy, limit are c to d into integrate with respect to z and the function in this case is hz and the limit of z in this case is e to f. So by directly in a one step you can have an answer. Only in the case we can split this function in this form. One function as a x, second as a y, then as a z, and the limits are constant. Right now we can directly apply this result for this example. Why? Because we can create a three different function. One is a function of x, that is x square. Second is a function of y, that is a y square. Another is a function of z, that is a z square. Even the limits are constant. Directly take the integration of x square, that is a x cube by 3 into integration of y square with respect to y, that is a y cube by 3, into integration of z square with respect to z, that is a z cube by 3. Now substitute the limits of x. X limits are 0 to c, y limits are 0 to b, z limits are 0 to a. When you simplify this, you will directly have this answer, that is a cube into b cube into c cube divided by 27. But this result is not applicable whenever we are not getting this form, as well as the limits are not constant. For example, in the next case, we need to find the triple integration of this function. This function we cannot separate in form of x only into y only into z only, because they are operated with a negative sign. Moreover, in this case, you will observe the limits are not constant. Now we need to learn how to write the limits in this case. Whenever we have the direct defined form of the reason, in that case, if it is mentioned, find the triple integration of this function or any function with respect to these variables. It is not necessary to take the same format, means first with respect to x, then with respect to y, then with respect to z. Depending upon the reason, we decide the variables here. Like in this case, x limits are constant, that is 0 to 1, y limits are 0 to x square, z limits are 0 to x plus y. In this case, z is depending upon two variables x and y. Definitely in that case, we will take the most inner integration with respect to z. Why? Because it is depending upon both the variable x and y, and here we can directly take the limits of z 0 to x plus y. After that, we need to observe in this case, then y is depending upon single variable, directly take the limits of y 0 to x square dy. Then with respect to x, that is 0 to 1. So keep in mind, whenever such domain is defined, the variable which has a constant limit that must be evaluated at the end, means the outer integration limit for that variable. Suppose in case you are taking in the same way, first with respect to x, then with respect to y, then with respect to z. The limit of x is 0 to 1, the limit of y is 0 to x square, the limit of z is 0 to x plus y. Now when you take the integration first with respect to x, the answer is in form of y and z, because when you take the integration with respect to x, we have x, y, z variable here. After substituting the values of x as 0, 1, you will get the function in terms of y and z. Then we take integration with respect to y. When you take the integration with respect to y, we have the variable y and z, because we have already done with the x. But when you add the limits in this case, now the function is depending upon x and z, and that is the incorrect. Why? Because we are already done with the variable x. Once we are done with any of the variables, after that the function is only depending upon the remaining variables. So it means that is the incorrect approach. Now, how to evaluate the integration in this case? Now let's evaluate integration first with respect to z. In that case, x and y is constant. Integration of a constant with respect to z is z. So we can write 2xz minus, in this case, yz minus z square by 2. And the limit of z is 0 to x plus y. And the remaining two integrals are as it is. Then substitute the value of z is equal to x plus y minus, then z is equal to 0. We have 3x square by 2 minus 3y square by 2 dy dx. Now take integration with respect to y. In that case, this term is constant. Constant integration is simply y minus this 3 by 2 as it is, y cube by 3. The limits of y are 0 to x square. and the outer integration 0 to 1 of dx as it is. Now substitute the limits of y, put y is equal to x square, then minus y is equal to 0. We have integration from 0 to 1. The function is 3 by 2 x raised to power 4 minus x raised to power 6 by 2. Now take its integration with respect to x, that is 3 by 2 x raised to power 5 by 5, because its integration is x raised to power 5 by 5 minus, in this case, x raised to power 7 by 7 but multiplied by 2, and the limit of x is 0 to 1. Substitute upper limit and a lower limit. We have in this case, this is equal to 8 by 35, and that is the final answer in this case. Next question is, find the volume of solid enclosed by x is equal to 0, y is equal to 0, z is equal to 0 and x plus y plus z is equal to 1. Now how to proceed with this type of a question? We need to identify how many variables are there. There are 3 variables and the question is about the volume. If there are 3 variables and the question is related to the volume, in that case, we can calculate the volume by taking a function as a 1 with the 3 integration with respect to each variable. Now, it is up to you whether you want to take first with respect to x, then with respect to y, then with respect to z. But right now, I am taking first with respect to z, then with respect to y, then with respect to x. As per this one, it says that it is a solid. The boundaries are represented by x is equal to 0, y is equal to 0, z is equal to 0. That represents the coordinate plane. And there is a plane that is x plus y plus z is equal to 1. It is a slanted plane intersecting in the first octave. Now the challenge is to determine the integration limit for these 3 variables. Let's start with the innermost integral, which is integrating with respect to z. From this plane, we can express that z is equal to 1 minus x minus y. Since z is a bounded, means this region is bounded by the plane z is equal to 0 to 1 minus x minus y. So here we can take z as lower limit 0 and the upper is 1 minus x minus y. This means for every fixed value of x and y, z varies from bottom to the top of this slant plane. Next, we need to determine the limit for y. For that, from this equation, when z is equal to 0, find the value of y. When z is equal to 0, we have equation x plus y is equal to 1. What does it mean when z is equal to 0? It means right now we are done with the z-axis. Now we are working with the shadow of the solid on xy plane. And we have 3 equations in this case, that is x plus y is equal to 1, second is x is equal to 0 and the third is y is equal to 0. Now with 2 variable we know that how to take the limit. So basically in xy plane we are getting this is as a y is equal to 0, this is x is equal to 0 and x plus y is equal to 1 line is a straight line that intercepts at the point 1 1. Obviously, if it is a solid enclosed by these 3 curves and this, it means it is a bounded region. So over here the bounded region is here. Now we need to take the limit first with respect to y. How to take this one? Take a line parallel to the y-axis passing through this region. Entering curve is y is equal to 0. And exit curve, this line is x plus y is equal to 1. From here the value of y is 1 minus x and that is the upper limit. Now we need to take the integration with respect to x. For that, take the lower values of x and the maximum value of x and that is from 0 to 1. Or we can directly substitute y as 0, z is equal to 0, the maximum value of x is 1 and the minimum is already given as 0. Now evaluate this integral. So in this case, first we need to take the integration with respect to z. When you take integration with respect to z, we have this. Now substitute upper limit minus lower limit. We have this form. Now integrate with respect to y. When you integrate with respect to y, constant integration with respect to y is y. X integration with respect to y again x into y because x is constant, and integration of y is y square by 2. Now substitute upper limit and lower limit. We have this form. Simplify this, you have this form. Then integrate this with respect to x. That will give you 1 by 2 into x minus x square by 2 plus 1 by 2 as it is. This is x cube by 3, that is 2 into 3 is 6. Substitute upper limit and lower limit. Final answer in this case is 1 by 6.